turned this to a video. All right, so we're going to go over Nix Language and see if I can help you understand it. At the same time, I'm going to review my stuff. Usually in my videos, I actually read everything because I'm learning it the first time. But let's try to just get through this quickly, you know? So you need to install Nix. You can just go to the website. It's not hard to install Nix. And remember, Nix is both an operating system, packaging manager, and a way of life. Just kidding. Well, half kidding, half joking. So here we're talking about Nix, the packaging manager. It's actually also a language. The packaging manager uses a language. So when Nix is annoying because like it's an OS, it's a packaging manager, and it's a language. So when you say Nix, it kind of means different things to different people, right? But we're going to be learning the language, and we're going to be doing that probably through Nix Shell, which comes with which comes with the packaging manager. If you have Nix OS, great, but you're not required to have Nix OS. You can just install Nix the packaging manager, and you'd be able to follow along here. So they think that it will take an hour if you're familiar, and 30 minutes if if you're proficient. Probably going to take us longer because we're going to go probably play around with examples. So it looks like I've forgotten about this, but there's a repl. And we can just do stuff. 1 plus 2. Nice. And how do you exit? Control D exits. And then here is an object. So, you know, like in TypeScript, you have object sort of things. This is an object. It looks like JSON, right? So we can have an object. This is the key, and property key, and this is the value. And now we have a equals 1. And then you can do something like a is equal to another object, b is equal to 2. I have to remember. This closes this. This closes that. So now we have a is equal to, I forgot the thing that makes it spit everything out. Or Elixir maps, yes. But here what they're showing you, instead of like nesting it like this, you can just do a dot b is equal to 2, and it'll do the thing for you. So there you go. Oh, fully evaluate does not match. Try prepending $p to the input expression. How the hell do I do that? This? Okay, so we just do this. There it goes. Now it prints the whole thing, right? And then you see my old one where I did this. It's the same thing. So these two are equivalent. Okay, so now we have a Nix file, and the way we can, let's make a Nix file. Thanks, B. I forgot so much. I'm so ashamed. File.nix. Shit. And in here, we're just going to do 1 plus 2. So we have an expression, right? See that? So we're not going to type it in the REPL. Instead, we want to run it. So this is going to instantiate the expression. And there we go. We have 3. And I assume we can edit the same thing. Whoops, that's not what I wanted. And we can turn this to a dot a, what the hell? A dot b is equal to 1. And then we call Nix instantiate. And there we go. There's probably, what is it, minus print here? Ugh, help me out. I've forgotten. But anyway, it's the same thing. We just have to find the flag for it. It uses lazy evaluation. If you want to not use lazy evaluation, use minus minus strict. Oops. So here we go. Strict. There we go. Look at that. Thanks, B. So now where it prints out the evaluation, the full thing. White spaces are used to delimit lexical tokens. Otherwise, they're insignificant, so it doesn't really matter. So we also learned about a let expression here. If you're familiar with functional programming, then this probably isn't too surprising. So we'll make something like x is equal to 1 in, and then what do we have before? It was like a dot b is equal to x. There we go. So you see that? See what I did there? Now we were able to set the variable, and now when we run it, it prints out 9 instead over there. So let is basically doing all the setup here. You can do multiple lines here. Whatever, right? We're not using it here. But yeah. So there we go. We have another object where we use two variables. Names and values. Values in the Nix language can be primitive data. Oh, I'm not supposed to read. What is this saying now? I don't know what it's saying. So I don't know how people just like speed run these things, because what do they do? It's like, what are they saying here? You're gonna miss something. Attribute sets. So the name here is an attribute set. This is basically a map, right? And you can see here, this is an attribute set. It's probably a pretty bad example. It kind of makes you think that these are types, but these are just like attribute names, just like A, B, and C. I guess they think people know JSON, so these are similar things here. Which means that if we go back to our example here, you know, we can have like greeting equals hello world, right? And we can also have outro is equal to 3. And here we have a string. You see here we have a string, but obviously outro number is equal to 3. This is a different data type. So you can see that they have the string things there. So we have booleans here, we have strings. It looks like we have nulls. Let's move on. Attribute names usually don't need quotes. List elements are separated by white spaces. Right. So this is an interesting thing. I think Haskell does the same thing, doesn't it? It's been a while since I've used Haskell. But I think we can just make my list here and make it equal to 1, 2, 3. And there you see my list is elements 1, 2, and 3. I think it'll interpolate numbers here. Yeah, is 1, 2, 9. It put X here instead. Oh, right, recursive sets. So, usually if you have something in here that inside of your attribute set that refers to another item, that doesn't work. But if you want to make it work, you have to put in recursive in here so it knows to evaluate it based on the dependency chain. I think I've gotten bit by that. but you take a performance hit, so don't do it just because you want to do it all the time. We already did let in. We already showed it. Nothing surprising here, right? You guys get that, right? You give it two numbers, and then we can just add them. So you need semicolons to separate here, and then the last one is just an expression, so you don't need anything there. Ah, okay. So where's the in, let in? What's it trying to say here? Maybe I'll just ignore this. Only expressions within the, only expressions within. So here we have a let. This is the let. X is equal to 1 in X. I see what they're saying. So they're basically saying that because we have a let here, right, that this X here is only available within this in. So you can't use it outside. That would be kind of like outside the scope of it. Attribute sets with a dot. We already looked at that. C is equal to name is equal to Elise. What I do wrong? Oh, it's just not used. So we're going to return two things here and C. Whoops. Too many languages. Okay, so it's just saying that we can access this by typing c.name to get to an attribute. So my name is equal to Elise here. That's what that's saying. With expression allows access to attributes without repeatedly referencing their attribute set. So if you don't want to type a.x, a.y, a.z all the time, some attribute set is equal to, we have this. Okay, so now we have this thing called some attribute set, right? And it has A, B, and C. And then let's say I want A and B. I can, in here, say with some attribute set, and then you put a semicolon. So now it's going to prepend some attribute set. So I should be able to do first A. Fuck. Second B. Right? First 10, second 5. And you can see 10, 5 here. So this got basically replaced, so I didn't have to type some attribute set dot first, which I guess should still work, right? Yeah. No. Oh, whoops. That's not what I meant. That's not, I said the wrong thing. So I don't have to type some attribute set dot a here. That's what I meant. And yeah, that works. It's the same thing. I just don't need to type this. It's like an alias in Elixir. They used a list here. I used attribute set. Doesn't matter. All right, let's keep going. We got through this. Only yeah, some kind of scope thing. I'm sure it's obvious. Inherit. I always got confused between inherit and with. So let's see. Inherent, inherent and inherit are not the same words. Inherit is shorthand for assigning the value of a name from an existing scope to the same name in a nested scope. You see, this is why, like, this documentation just makes it a little complicated, because if you really read it and you pay attention, it makes sense. All right, but we can look at it here. I see, yeah. So it's just basically taking the pair, key value pair. So remember when I had to like fake and make like new keys here? Instead, I could just inherit this stuff. I wonder if I can string these two things along. No, no, no. You don't want a string. They're doing two different things. So if you want to just, if I want to just bring down, no, I do. So with this, and then I want to inherit A and B. Oh, that goes inside. So what I'm thinking is that this with makes it so I don't have to type some attribute set dot A. You see what I mean? And inherit's going to make it so A equals 10 shows up. Look at that. We figured it out, guys. We figured it out. Did that make sense to you? Do you want me to explain it real quick again? So this one with the with just basically means I don't have to type this. And then in here, I'm returning an attribute set. And with the inherit, I'm just grabbing some attribute set dot A and some attribute set dot B and just bringing it down here. And that's why I get A equals 10, B equals 5 when I ran it. Hopefully that made sense. So inherit basically brings down the pair, the key value pair, and with basically means an alias. You don't have to type it. And you can limit what you inherit. Oh, this seems like shorthand for basically what I just did, right? So we did it with a with, but looks like I can basically do this and get the same thing. So this is shorthand for the with. String interpolation is always good to know. So we want to interpolate a string. Name equals Elise, and let's put in A in here. Do you guys think this will work? Undefined variable A. Uh-oh, isn't this how it works? Probably we just can't do it. Yeah, we can't do that. So let's put a new thing in here called name is equal to foobar. And then we're gonna use, well, is it like this? Uh, cannot coerce integer to a string. Oh, it only works with strings. I'm sure we'll learn how to do that in a minute. Foobar Elise. So I grabbed my name from up here and printed it over here. Notice that I had to type in some attribute set. So if we use with and we use some attribute set, isn't this how it worked? God damn it. With a. Expect binding. Inherit. Oh. No? Unused with. Ah, here. There we go. So the width comes where you're trying to access it. So it didn't belong here. It belonged on the right side. And then this part is going to have the width enabled. And so C, it's going to turn it into some attribute set dot C dot name. And then so we get foobar Elise, right? It's going to go up to C here and get my name. And then when we run it, we get name equals foobar Elise, right? Oh, did I not type it here? No. Aha. New bar. Let's see. So this will turn into foobar Elise new bar, right? There we go. Perfect. Thanks, B. Did I type it over here? Did I do this? God damn it. Okay, we did inherit string interpolation. Only character strings can be in string interpolation, so how do we do it without... Oh, they don't really explain it. You can concatenate with plus. So we added a whole bunch of ones at the end with the plus concatenator operator. Right, sometimes we'll see, but no braces. So if we see this, this is not a concatenation. All right, indented strings, multi-line strings with two. Okay, so let's just clean this up. intro text. Here is my biography. I didn't do well in school and missed a lot of classes. Still, somehow, I got a job. And now let's just try to print it out. Well, it did it. It put in like new lines here, but it's not formatted when it prints it out. That's okay. File systems, file paths start with slash, so we can like give it slash stuff. So here's shell.nix. Is that how it works? My file equals home nixos projects nix. You see it turned it into an absolute path there. Built-ins to string, perfect. All right, so this turns the A into a string, so we'll get our intro text with the number 3 added to the very end. So 3, there's our 3. We learned about the paths already. Angle bracket syntax. So this is where we can look up paths. It tries to find this thing in your path, I guess. So that means I should be able to just do my packages is equal to Nix packages. And then here we're just going to print it out and we'll see where our Nix packages is. It's in Nix store this thing. That's where our packages are. And I'm guessing it's an actual like directory. There we are. Yeah, so it has all this stuff in it. All right, now we're going to learn about functions. Functions. Let's make a function. Add to. And it takes in. Oh, this is just yeah. It takes in a single parameter and then returns it plus 2. Then how do we call it? You just do it like that. So it returned 12 because we made a function add 2 here. It takes in one parameter and there's the function body here. And if we want to do like add, and it takes, if maybe such a thing already exists, we're going to put in one add two here. Is this, why does it not happy there? Previously defined. Oh, just because I made my syntax was wrong. Okay, and then my add is equal to my add 10, 20. These are just keys. Like maybe it's confusing. Key 1, key 2. Right? So here's going to call my first function, my second function over here. And we have key 1 is 12 and key 2 is 30. So that's how we do those functions. Did we skip anything? So yeah, what was the syntax? You got a colon, and then you have your body. This is a little bit like lambda calculus. You're basically passing in these two parameters, but really they're just functions. This is like a function that takes a single parameter that takes in a function that takes a single parameter, and then it binds it. So they're always really taking one parameter, but you know, you can think of it as a function that takes two parameters. And yeah, like probably often you could probably like we didn't really play around with lists much, huh? No, let's not. I won't bother. So we can also take in parameters that is an object, that is an attribute set, and have a default. Not too complicated here. Let's see if we can make one that takes in a list. And it takes in, I'm not really sure how to even say this. Well, we'll do it once we get to a list. We'll just make an object for now. So my function is equal to, and then here we have how it's defined. We put in the keys, A and B. Those are the keys within that object, and the function can actually return something, right? It can do add to. We might have to make this recursive. And now we pass it in an object that has A1, B is equal to 2. So we got 5. Oh, because I did add 2. I should have just called add. My bad. My add. So this should be 3. Oops. Yeah, my add. Why doesn't my add work? My add takes in 8x plus y. Why doesn't this work? I don't think you can supply a list as input to a function because you need the names. Yeah, I was wondering if they had pattern matching for that, but I'm guessing not. Oh, because I'm stupid. There we go. I had a I had a plus here, and then this would add them and pass the single parameter, but it needs two parameters. There we go. Um, yeah. I see you said it. I have a little bit of a delay on my side. Um, we did calling functions. We can return functions. We can have curried functions. That's what we were talking about earlier. X, Y, X plus Y is really a function X that takes in a function that takes in a Y and adds the two. So it basically looks like this. Um, and you can see in here that this thing is a function too. So it basically curries, which means you should be able to do something like my add 10, right? So here, just saying it's unused, yeah. That's okay for now. Well, we'll get rid of this. So here it's going to return a function because my add actually takes two parameters, right? So it's going to return this function that is a function that takes in a y. So if I run this now, I get a lambda. But now I can do value 2, which takes value 1, which is a function, and I'll pass another function like 100, another value like 100. Undefined name. I thought I could do this. Oh, I got rid of it, that's why. There we go. And then when I run this, I get value equals 110. So this is a partial function. It's not fully instantiated. And this one we fully instantiated because now it can actually return the value, the body. There's nothing more that for it to actually continue with. So to be clear, this is a function. That's what that is. Why did it get rid of my crap? There it is. Curry function. Attribute set argument. This looks like pattern matching maybe. Let's see. Yeah, I think we already did this. That's exactly what this is here. We need a function that takes in specific, it needs to take in a parameter that has a and b. So if I call my function here and I pass it in like 10, oh my god, please stop with the different languages. Ah. I can't. I can't. There we go. Value equals 30 because we added these two numbers together, right? But if I pass in an extra thing in here, I think it's going to be unhappy. Yeah, it's unhappy because I think you need something in here like this to tell it can take extra parameters. There we go. Otherwise, it's going to have to match exactly. Now we can give it default values. So any one of these can take in a default value, like let's say b is 10. So now I can like skip passing b, and it should basically add 10 and 10 and return 20. So my value 3 should equal 20. Yep, and it is 20. I don't know how to like, I can't, oh, I have a restream page here. 1 second, I just want to ban this block list. All right. So we did the default values. You can have multiple default values. Additional attributes, we just learned that. Named attribute set argument, at pattern, at syntax. An attribute set can be given name as, what is this saying? Oh, this is just the rest of the args here. I see. So if you want to get the rest, you write it as args. Here, think it's just args, right? And then what we'll do is we'll add them, and we'll add them. Does this make any sense? You see it's 50 here, val3 is 50, and that is because we did myAdd A and B. A and B is just 10 because B defaults here to 10, so it's 10, 10 is 20. So it's 20, and then we add 20 to C. C is 30, so it should return 50. Was it 50? Yes, it was 50. Hope that made sense. I guess there's no type checking, so C, like, I could just, if you don't pass a C, it probably breaks. Let's not pass a C. Yeah, it's like, attribute C is missing. Function library, so we have a bunch of built-ins. ToString, we already learned that one. Import is really important. Import basically brings in functions, right? Most built-ins, a notable exception is import. So it means you can just call import. It takes a path to a Nix file, reads it, evaluates the contained Nix expression, and returns the resulting value. That's why we often do, let's say, like Nix packages path is equal to Nix packages, right? So here's this is going to look up the path like we figured out earlier. And I guess we can just do like val4 is equal to import Nix package path. I don't know what this is going to do. There we go. Val4 is lambda. So it's a function. Whatever Nix packages returns, it returns a function. But that's basically what it does. Packages lib. All right. I need to take a break to, I'm so close to the end. I was kind of wanting to speed run through it. How much time have we taken? Where is the stream time? We're at 1 hour exactly. So 30 minutes. I guess we're not advanced. Or we just like to play around with stuff a lot more, right? I think I'm going to make tea. So let me see. No, there's no way for me to. Oh, yeah, I can pause the recording. Pausing recording. I think it's working. All right, so where are we? So we have the Nix library functions there, and then we have the built-ins, and then we have the library functions. So Nix packages has an attribute set called lib. And we have all the functions in lib, and we get it through packages.lib, as it's usually called packages by convention. So if we import this, I see. Let's look at our code again. So we've imported this, right? So this is returning a function. So when we import this, this is evaluating all of this. And now if we really break this out, we basically can take val4, which is basically this function, and we call it with the empty attribute set. So this is actually calling the function now, and we're not passing any variables. Let's see what this gets us. A whole bunch of Stack Overflows. It's probably too big because Nix packages is probably huge, right? Anyway, val5 you would call like kind of packages, right? It's kind of the packages. So now I can do kind of packages dot string dot, oh wait, why is it not working? This is import. This should work, no? What's it saying? Oh, right. Kind of packages dot lib dot strings dot to upper. I'm going to pass it in a string, all lower. No, I don't want to print this though. Shit. We should put this up on the let so we don't print this. Otherwise, it's going to try to evaluate it. It's going to be too much. So we're just going to do this. We import it here. So we get the packages path, and then we call it like packages imported, right? And now we're going to do packages imported. We're going to actually call it. So we're going to call packages invoked. What happened here? unused binding. Why does the, oh, because it's recursive. Shouldn't this work? Maybe I need to make this a recursive thing. Okay, so I just made a recursive attribute set so I can kind of like call the previous versions, right? Nix packages, invoked, and I'll just call this like P to make it really short. Looks like add2 is unused. Guess we got rid of it. And then here, we're going to call P. You see that? Oh. Oh, now we actually have access to it. So upper should be an uppercase version of this. Ah, fuck! Attribute lib missing. Why? Packages lib. Isn't this the exact same thing? Import packages. Packages invoked. Ah, here. No, that's why. Because I need to call p.packages invoked. There we go. So all up, the upper one is now all lower, but in capitals, you see? My mistake was I forgot to call, like, we have an attribute set here, but I needed to call packages invoked in order to get the attribute set lib on it. That is equivalent to this whole thing here. I just wanted to break it up so you guys see that there's nothing magical here, that this is just a path. There's nothing special about this other than it's in your path and it found it, right? And then here, we're importing it, so it's going to evaluate it. And then we need to actually call the function that is returned by it with something. I think there's a whole bunch of overrides you can give it. That's how Nix basically configures stuff. But this is how it all works. So that's where we are. Impurities. So far we only covered pure expressions. There is only one impurity in the Nix language, reading files from the file system as build inputs. Whenever a system file path is in string interpolation, the contents of the file are copied. Okay, so that's pretty cool. I remember that. So what we can do here is we get the path to my file is equal to file.nix. So you can see here that I'm referring to my file, right? And now I'm going to interpolate my file over here, my file. And this is going to grab the contents of my file, turn it into a string, and then call toUpper on it. So uppers should include my file now itself. Ah, shit. Oh, it's only going to print out. Contains the store path. Okay, so it only prints out the store path, Nix store. It doesn't print out the contents of the file, just where it is in the Nix store. Okay, that's fine. We're done with the language. That's it. Like, these are just built-ins now and other things to use. But if you've gone this far, you basically know the language. Um, I think we will. I think I'll stop here because it's a nice thing. Like if you get this far, you can say you know the language. You can look at just about any Nix file and say like syntactically, I know what I'm doing. I know I know what this is. This is an attribute set. This is a list, whatever, right? And the rest of it is just learning the built-in functions and learning the library. What's it called? Packages library? Packages lib. So, yeah, it's a good refresher for me too, right? Like, if you didn't want to like follow my videos slowly, this is just a faster version. I'm not sure what like it feels like to someone learning Nix. Do you think it was way too fast? I kind of just switched back and forth a lot. I'm not sure. But people will maybe leave comments. We'll see. I don't think it hurts to do this every so often, for myself and for people learning, because maybe they'll stumble along a better one for them, a better version of this video. But yeah, I have newfound interest to like use Nix to actually make my own derivations and compile stuff. I use it a lot for my work and my life, but I didn't go very far with it. So I want to go a little bit further. So I'm going to stop the video part now.